Hey everybody, Greg here, and I just wanted to do a review of all the concepts and equations for all of PS2 in a systematic way, sort of putting it all together, and then at the end I'll just mention a few study tips. So we dealt with a lot of different things in the class. We've dealt with, so there's two big differences. So there are certain situations like, you know, this here where we have some statics problem, or we have some problem where we're dealing with drag or something like that. And then we had a lot of, and then over here we have like tendons. We got have some forces, and then separate from that we have all of these fluids, and there are some particles here. So in the first case we had just one object, and we were dealing with the dynamics of that object. So that's what all of these were. So in green, I sort of boxed. We have the statics problem. So it's a one rigid object. The bird is one rigid object, and then we also had these situations where we're dealing with many objects. So fluids is a bunch of little tiny particles, and we're only dealing with the bulk dynamics of it. Then after we dealt with the fluids, Einstein told us that fluids are made of little tiny particles, and then so we dealt with all of the little particles that were inside the fluids. So there's single objects, and then there's many objects, and so we started the class, doing force of the many objects, kinematics of them, statics, and then we eventually went to the bulk dynamics of fluids, and Boltzmann's constant, and Boltzmann distribution, things like that. So then when we're dealing with so what I'm going to do in this review is I'm going to start with the dealing with one or a few objects, and I'll break that down into two parts, which I'll describe in a second. And then I'm going to talk about the fluids, the second part of the class where we dealt with fluids and small particles that make up gases and fluids. So when you're dealing with one or a few objects, there's two ways to describe it. There's before and after, and then there's detailed dynamics. So before and after are things like change in momentum and change in energy. So both of these are when you have an isolated system, and if you have an isolated system, you know that you don't have any outside things that are causing a change in momentum or a change in energy. So you just have to look at something like some final position and some initial position. And then with detailed dynamics, this can describe what a particle is doing in not just at 2 points, the final and initial, but over some period of time. And there were 7 situations where we dealt with detailed dynamics. There was statics. At any time we knew that it wasn't moving. There was motion at a constant velocity. We knew what the velocity was at any time. There's motion with constant acceleration, and we knew what the velocity was, say, initially, and then with the acceleration we could figure out what it was later, and we could figure out the position later, but we basically could figure out what it's doing at any moment in time. Uniform circular motion, we could figure out basically what the speed and direction is at any time. Accelerated circular motion, and with that we can figure out the position, velocity, speed, also angular position, angular velocity, angular speed for this. And then we did some general rotation, things like precession. And then we had harmonic oscillations, dealing with sines, cosines, and all of that. So those were all the situations where we dealt with detailed dynamics. So first I'll go through before and after, change in momentum, change in energy stuff, starting with the definitions, and then I'll look at the detailed dynamics.